Okay, get ready because we're going deep on brain-computer interface.
BCIs. Yeah.
BCIs, yeah. You sent over a ton of research, so I can tell you're ready.
Definitely. It seems like there's a lot to unpack here. Everything from how these things work to, really big philosophical questions.
Yeah, we're talking thought-controlled robots, telepathic communicator, like the whole thing. I mean, this stuff used to be pure science fiction.
Right. And it's becoming reality, which is really something.
Okay, so to get our heads around all of it, let's start at the beginning. What exactly are BCIs?
In the most basic sense, they're a direct connection for communication between the brain and some kind of external device.
So instead of using your hands, you could just use your thoughts to, like, move a computer cursor?
Yeah, exactly. Or even a prosthetic limb. That's one of the big areas of research.
That's wild.
And it really does represent a huge shift in the way humans interact with computers. Schneppat, who wrote one of the essays you sent, really hits on that point.
So it's not just about the gadgets themselves, it's about changing our whole relationship with technology.
Exactly. And to understand how that relationship might change, it's helpful to look at the different types of BCIs that people are working on.
Okay, so break it down for me. What are the main types?
Well, there are three main ones: invasive, non-invasive, and partially invasive. So, first, invasive BCIs are implanted directly into the brain tissue.
So those are going to give you the best signal, but it sounds pretty intense.
Yeah, they require surgery, which obviously has some risks associated with it. Then you have non-invasive BCIs. Those use external sensors, like an EEG, to pick up the brain's activity.
So that's safer, but I'm guessing the signal's not as good.
Yeah, that's the trade-off. It's much easier and more accessible, but the signal quality isn't quite there yet. And then there's partially invasive, kind of a middle ground.
Best of both worlds.
We're hoping, but that's still in the early stages of research. Still a lot to figure out.
Okay, so we've got these different ways of connecting our brains to devices, but how does it actually work? Like, what's the science behind it?
Okay, so let's picture someone trying to control a robotic arm with their thoughts. It starts with signal acquisition. That's where electrodes, either implanted or just on the scalp, pick up the electrical activity that neurons make.
So we're basically listening in on the brain's electrical signals.
Sorta, but it's not that simple, because those signals are messy. So then you need signal processing, which uses algorithms to clean up the signal and pick out the patterns that mean something, like move left or grasp.
It sounds like trying to find a needle in a haystack.
It's a huge challenge, especially with the non-invasive BCIs, because you have all this extra noise to deal with. Imagine trying to pick out one voice in a whole stadium full of people.
Whoa, okay, that makes sense.
And then after that is encoding and interpretation. That's where those brain patterns get translated into commands that a computer can actually understand. This is where machine learning is really important, because the system has to learn what those patterns mean.
So it's basically like the BCI is learning to read your mind.
Yeah, that's a good way to put it. It's learning to recognize the specific signature of your thoughts and what they mean. And then the last step is deployment.
That's where the magic happens.
Right, that's where this signal gets sent to the device and makes it do whatever you want it to do. The arm moves, the cursor clicks, whatever.
So your intention becomes a real-world action.
Yeah.
But going back to what Schneppat was saying, how does all of this change the way we interact with technology?
I think one of the biggest changes is that before, we've always been limited by our physical bodies. Like we need to type or click or swipe. But BCIs let us bypass all of that and connect with technology directly through our thoughts.
That's such a more intuitive connection almost.
Yeah. And I think that has huge implications for what we can do with technology and maybe even what it means to be human in a world that's so driven by tech. It really makes you think about how we relate to technology and maybe even to ourselves when you start blurring the lines like that.
Totally. So we talked about how BCIs work, but I think it gets really interesting when we start talking about the applications. Like, where could this go? What's the potential here?
One area that's super promising is neurorehabilitation, like stroke patients regaining motor function or people with spinal cord injuries being able to control prosthetic limbs just by thinking about it.
That would be life-changing for so many people. Giving people back their independence, it's amazing.
And it's not just about restoring lost function. It could even enhance the abilities we already have, pushing the boundaries of human potential, that sort of thing.
Okay, now you're talking. Like, what kind of enhancements? Give me the sci-fi version.
Well, some people believe we could eventually communicate telepathically, share thoughts and emotions directly with other people. Just imagine what that would do for human connection.
I mean, that sounds incredible, but how would we even... don't we need to understand how thoughts even work first? Are we even close to that?
Right, and that gets to the fact that the brain is incredibly complex. We're still just scratching the surface of understanding consciousness, let alone actually manipulating it. But who knows what the future holds, right?
It is exciting, but yeah, it is a little bit scary how fast this is all developing.
It is. And
Yeah.
anytime you have a powerful technology, you have to think about the downsides too. Like, what if it's used for bad purposes?
Yeah, that's what I was wondering. Like, could someone hack into a BCI and steal your thoughts? Or even, like, control what you do?
Those are definitely valid concerns. We have to have really strong security measures
Right.
and make sure people's brain data is protected as this stuff gets more advanced.
So it's not just the science, it's the ethical and legal stuff, too.
Yeah.
Figuring out the rules of the road as we go.
And that's something Schnepphat talks about too. The philosophical side of all of this. If we're merging minds and machines, what does that even mean for what it means to be human? It's a big question.
We're kind of in uncharted territory here. It's not just about the tech, it's about redefining what it means to be human in a world like that.
And that's why it's important to be having these conversations now before it's too late.
For sure. Okay, so we have security and ethics, but what about access? Will this be something everyone can use, or is it just going to be for rich people?
That's a huge question. If we want this to benefit everyone, we have to make sure it's affordable, not just another thing that makes the gap between rich and poor even bigger.
Because it could go either way, right? Any new technology, you have to think about who's going to benefit from it.
Exactly. We need to make sure it's a force for good for everybody, not just a tool for the powerful.
So we need to think about the social and economic side of this, not just the technical stuff?
Yeah, and we have to be proactive, shape those impacts, not just wait and see what happens.
Wow, this is a lot to think about. I think we've given our listeners plenty to chew on already. But we're not done yet. Stick around, because in part 3, we're going to dive into what the future of BCIs might look like, and what we can do to make sure it's a future we actually want. Welcome back. We're wrapping up our deep dive into brain-computer interfaces.
BCIs, yeah. It's been a pretty fascinating conversation.
It really has. We've covered how they work, the ethical questions, and I think now the most exciting part is thinking about where this technology might go in the future.
Yeah, it really does feel like we're on the edge of something huge here.
Yeah.
So much potential, but also a lot of challenges.
Exactly. We can kind of see that a revolution is coming, but we don't know exactly what it's going to look like.
One thing that seems pretty clear, though, is that BCIs and artificial intelligence are going to become even more intertwined. Like we talked about, AI can make signal processing better, make the user experience more personalized, maybe even create whole new ways to use BCIs.
So it's not just about BCIs getting better on their own. It's about combining them with all these other amazing advances in technology.
Right. Just imagine AI that can actually learn from your brain activity, not just interpret it, constantly adapting and getting smarter based on what you're thinking.
It's like having an AI partner that helps you explore your own mind.
And as AI gets more powerful, it might help us solve some of the problems that BCIs are facing right now. Like maybe we won't need those invasive surgeries anymore. Or maybe AI will be able to make sense of those really complex brain signals that we're struggling with now.
So AI could make BCIs easier to use, more reliable, and just way more powerful overall.
Exactly. But we have to be careful here, because the more powerful something is, the more important it is to use it responsibly. Which brings us back to what Schnepphat was saying about the philosophical side of things.
Right. It's not just about the tech itself. It's about what it means to be human in a world where we're merging our minds with machines. It's a big question.
Yeah, and we have to start thinking about the answers now while we still have time. Like, how do we make sure BCIs are used to help people, not to control them or take advantage of them?
We'll have to protect people's privacy, their right to make their own choices, all that stuff.
And we have to be really aware of the potential for this to make inequality even worse. We don't want this to just be a tool for the rich and powerful.
Right, that would be a huge missed opportunity. This tech has the potential to change everything, but it'd have to be for everyone.
And that's why it's so important to be talking about this stuff now. Scientists, engineers, philosophers, policymakers, everybody needs to be involved in figuring out how to make this work.
And regular people too, right? Because this is going to affect all of us, so we should all have a say in how it happens.
Definitely. It's a big challenge, but it's also an incredible opportunity to create a future that benefits all of humanity.
Well, I think that's a good place to wrap things up. We've covered a lot in this deep dive, and it's clear that BCIs have the potential to change the world in both good and bad ways. It's up to us to decide what kind of future we want to create with them.
It's an exciting time, but we need to be thoughtful and careful as we move forward.
Absolutely. This is just the beginning of a much bigger conversation, and we hope you'll join us as we continue exploring this amazing field. Thanks for listening, and we'll see you next time for another deep dive into the world around us.